In this video, we are going to look at question 12 from the specimen paper. So in this question, we have a cyclist which is going at a constant speed downhill on a slope which drops down by 1 meter every 10 meters he goes. He weighs 100 kilos, and in total, during his journey, he drops by 100 meters. We are supposed to find the total drop in gravitational potential energy and the resistive force on the cyclist. So we are going to split this question into two parts. And as we know, the gravitational potential energy is defined as the product mgh, this is the mass, and h is the drop by 100 meters. And plugging in the numbers, 100 kilos and 100 meters, we get 100,000 joules. Now for the resistive force, we could of course somehow get it from looking at forces, but again, that will generally speaking be a messier solution than the neater alternative, especially because we already have gravitational potential energy. I would definitely go for the energy approach in this case. So since no kinetic energy is gained or lost, the gravitational potential energy at the top of the slope must equal the work done by the resistive force during this descent. The force done by a resistive force is defined as the force times the distance over which it acts. And when we isolate the force on the left-hand side, we get a ratio of the gravitational potential energy, which we already have, and we have to divide that by the distance travelled. So if the cyclist drops by 1 meter, we know that he goes 10 meters. And since the two are directly proportional, if he drops by 100 meters, then the total distance travelled is going to be 100 times 10, which is 1,000 meters. And as we can see, when we plugged in the numbers, we got 100 newtons. And the combination of these two answers was in the exam option E.